Hello and welcome to the online lecture series on the course of Object-Oriented Programming. In this video, we will start a new chapter, chapter 5, which is functions. We will cover the introduction of functions, then simple function and passing argument to functions. We will cover these three topics in this video. Functions are the very fundamental concept in C++, right? Function simply means when we group number of statements in program and give one name to it, right? So those statements which are being used repetitively in the main program body, right? And when we group them together and give one name to it, that is known as functions, right? So the idea of function is those statements which are being used again and again in the main program body, so you merge them together and give one name to them, right? And that is what simple function is, right? Now whenever you want to use those group of statements which you have grouped them together and given them a one name, right? And whenever you want to use them, you basically invoke them, right? So the word we use is called invoke, or simply call them, and that is called calling to a function, right? So you basically group number of lines, right? And every single line in a program is known as a statement. So basically you do not use the word line, you basically say statement. So you know that these specific statements are being used again and again, and they are consuming a huge amount of space, right? So the better idea is you group them together and give name to them, right? And whenever you want to use them in your main program body, you basically invoke them or you call them, right? That's what simple functions are. Now these functions are slightly different from the functions that you would have studied in basic mathematics, right? So the functions that you have studied in basic mathematics basically relate to variables, say x and y. So whatever the relationship between x and y is known as function. But in object-oriented programming or in any other programming language, the idea of function is different. And the idea of the function in programming is that avoid using the same statements again and again. And the reason of using the function is that you can have a good conceptualized organization of program. So the program will not be scattered, the program will not have so many lines for no reason, and the size of program will be smaller and it will consume less amount of space in the memory. So whenever if say you write so many statements which are performing the same function again and again, then they will consume huge amount of memory, right? But if you write those statements only once and you call them whenever you need them, then they will only consume memory for once. So there are three benefits of using the function. Very first is that the size of program will become compact, the size of program becomes smaller, and when the size of program becomes smaller, then the organization of program will become conceptual. It will be easy to follow the program, and then it will consume less amount of memory, right? Because whenever it is being called, only it will consume the memory, otherwise it will not consume any kind of memory, right? So these are the reasons of using the functions in object-oriented programming or in any other programming language. Now the functions are not the concept of OOP, right? So the OOP has two pillars. You remember the first pillar is objects and second pillar is classes. The function is the basic topic from the procedural or maybe from the structured programming languages. So you remember in the first week or maybe in second week I mentioned to you that when the size of program gets larger and larger, so what they did is they grouped certain statements which perform one task or one function, right? So the programmer basically grouped them together and given them a one name, and that is known as function, right? So the concept of function is actually borrowed from the structured programming language. It's not purely the concept of OOP, right? But it is being widely used in OOP. And the reasons of using the functions are very simple. One, is you organize your program conceptually so that you can follow it and any other programmer can follow it. Second, the size of the program becomes smaller because you will not write those recursive statement again and again. And third, it will not consume more amount of space, right, in the memory, because whenever you call the function, it only occupy space in that time, otherwise not. Right? Now, so the idea of function is you divide the program, right? Dividing a program, and that's simply known as function. Now, let me show you this concept by this image here. This is taken from the book of Robert Leffer. Okay. Now, this is the main program body. Consider this rectangular box is a main program body, which is like integer main and then those two curly brackets. And within that program body, there are a bunch of statements. Like, so these lines are basically indicates the statements. Right? And after every 3-4 line, there is one function being called. And function 1, again function 1 and function 1. And every single function has two small parentheses and then semicolon. Right? I will talk about syntax in later, but so this function is being called 3 times within the main program body. Now this function may be containing 10 lines, may be containing 15 lines, may be containing 45 lines, it depends. But it is not, the number of lines are not being written again and again. Only the function is being called and the function actually contains all those lines here. So whenever we want to have these lines, then only what we do, we call the function. And then function in result will give us a response. Okay? So this thing is called calling the function or invoking the function. Now the same concept in other programming languages, when you study assembly language in 5th semester microprocessor, then the same concept in assembly language is known as subroutine, or maybe in other programming languages it is known as procedure. Right? So the name of function is different in other programming languages, but the concept is very similar. The concept is you group statements together and give them one name. What statements? Only those statements which perform one specific task, right? And so you group them together and give one proper name to it, and the name of the function basically depends upon which function it performs. Let's say that the function performs measurement of distance, right? So you give an appropriate name to a function so that you can identify it, that what kind of task it is being performing, right? So I hope the concept of function is very clear to you. Now let me give you a very simple example which is given in textbook. So I'll explain to you before I run it. Now let me full screen. Now right here the program starts from here, library here, and then using namespace std. Now this thing right here is a declaration of function. And I'll explain to you what declaration simply means, but this is the declaration of function, right? And this is the main program body here, which starts with integer main. If you remember that every program body begins with this thing, and then this contains two curly bracket, and whatever is the main part of the program body will be written here. And now this is called the function definition. Right? Now what this function does is basically generates a 45 number of stars, right? So this function star line basically generates 45 stars in a one line. That's what it does. Now whenever you want to use the function, step 1 is you declare it, right? And once you declare it, then you can use in the main program body. So within the main program body, you only write the name of the function, and then you give two small parentheses and then semicolon. Now right here is the cout statement, that is data type, and then there is a space, and then there is a range here, right? And again you are calling that same star line here, that is the function again. And then again there are a bunch of statements like cout from this point until this line here. There is no semicolon, that means there is no need to write cout again and again. Only one cout will perform its function. So now there is a character which has a range of -128 to 127. Then there is a short has this range, integer, and integer is depends upon system whether it is 32-bit or 64-bit, and then there is a long has this range. So what this program does basically, On the top line there will be a data type, which are these one: character, short, integer and long. And then there is a range here. So what is the range? Range is like how much memory it will be occupying, right? So from -128 to 127 for the character, and this short in here. And again we have called the function star line here. So within the main program body we have called the star line 3 times: 1, 2 and 3 times, right? Now what this star line contains on the back side, it basically contains these statement, right? So within the star line what we have is like we have a for loop which starts with 0 and it ends on 44. So from 0 to 44 is 45. So for 45 times we are basically generating this star symbol, right? So this is a star is basically a character, so therefore it is given in single quotation mark. So see out. So this star line is a function which is basically generating 45 stars. And now we are using the star line in our main program for around 3 times: 1, 2 and 3. So it is not good idea to write this statement again and again and again. So always you should write it once in the definition of function and then you just call it. So whenever we call this function star line, it automatically jumps to this part here and execute it, right? Now let's suppose this line is executed and then this line will be executed, and then once we jump to this line, then automatically this line will jump the program to this function here. And when this function is executed, it will give us 45 stars and then automatically will jump back to the cout, right? So step 1 is function declaration, and then you call the function, that is called invoking. So calling of the function only happens in the main program body. So what is the main program body? The body which starts with integer main. So this is the main program, right? So if you remove this white star line and if you remove this white star function body from here, then we have only this main program left here, right? So this is the main program in which we basically call our function, and that calling is called invoking. And see, it mentioned call to a function. So call to a function means we simply jump to main function body, and that main function body is known as definition of the function, right? Now this line is called declarator. This line is called declarator, and within the declarator we have this curly bracket, and then curly brackets will end here, and this will define the function body. And in function body we basically mention the task of function, that what exactly this function will be performing. Now this function is performing the task of generating 45 stars, right? So we program the function body accordingly so that that function can perform that one specific desired task for which it is being dedicated. And then in the main program body we will only be calling it as many times as we want, right? So the benefit would be that it will not occupy space. Second, the program will be much more organized. And third, it will only consume space in the memory when it is being called. So it will consume memory for only once here, and then for once here, and then for once here. It will not consume memory for 3 times. So if you write this statement in the main program body, then the same it will be consuming for 3 times. But if you call the function, then this will consume space only for once. And now this is the idea of using the function. Now let me show you this thing on the code block here. So I have this program here, the same thing. Let me build it and then let me run it. Now see, this is the output. So these 45 stars are here, and then the second statement, which is data type, and then there's a space and range. So data type and range here. And again the function is being called, that is star line, right? So see here, the star line is being called. So star line will generate 45 stars here. And then again there are a bunch of cout statement, like 4 cout statement, and one is character, so character here, and then the range, which is -128 to 127, so range is here. Likewise short, integer, long, and again we have called the star line function. So star line function is called here, right? So whenever you call the function, it will be executed, right? And what function contains, it depends on the function body, and the function body will always be after the main program body. This is generally how we follow, right? So first step, you declare the function, right? And then, like, declaration simply means you need to tell the compiler, like we tell about the variables, like these variables we will be using in our program, right? So you need to tell the compiler that this is the declaration, means we will be definitely using this star line in our main program body. So therefore you have to tell the compiler that it is being declared now, and definitely we will use it in our main program, right? And in the main program you will only call it. So when you are calling it, you will not mention void here, right? And then after once the main programming body is finished, then you will define the function. When you define the function, you basically tells what task this function will perform, right? So the actual mathematics of the function will be done in this function body, right? In the main program body you only call the function and you execute it. That's all it happens, right? Now there are three main parts of a function. One is function declaration, then function call, and function define. So let me show you. Now this statement here is function declaration, right? This is function calling, right? Function call or function invoking, sorry. And then this is function definition here. So every single function has a three parts whenever it is being used, right? So first part is function definition, second part is function call, and third part is function define, right? Or function definition. Now what function declaration is? Function declaration is simply a prototype. By prototype it simply means that we will definitely be using this function in our main program, and this step is only to tell the compiler that this function will be used. That's all, right? And now the function declaration has two ways. One way is you declare it and then define it, and second way is you define it and then declare it, right? There are two approaches of function declaration. One approach is declare and then define, which is exactly what has happened in this program. So in this program we have declared the function, right, and then we have defined it, and this is the first approach. And second approach is you define it and then you declare it, which I will definitely cover in this video. But in this program we have declared the function, then once the main program body is done, and then we'll define it, right? So this is the first approach. Second approach is you define it first and then declare it. So by define simply means the actual mathematics. By actual mathematics I mean what task that function will be performing. So you do whole maths into those curly brackets, which are called the function body, right? Now let me tell you the theory of this void and parenthesis, what this void and parenthesis simply means. So whenever you declare the function, you mention the word void here, void, and then the name of the function, and then you give two small parentheses, and then you give semicolon. Now this void simply in English it simply means null, meaning nothing, right? And star line is the name of the function, and these two curly brackets contain the arguments, right? So the arguments are the input to the function, right? So these two small parentheses will be containing the arguments. Arguments means these are the input to the function, and whatever the task the function will perform and whatever the output will generate, right, it depends upon the function body, right? Now if this function is not generating any kind of number, right, then that function is known as void function. So this void means it is null, it is empty, it will not generate any number on the output side, right? If it will generate any kind of number, then what kind of number it is, like integer, long, float, you have to mention it. But because this function when executed will not generate any kind of output, right? So the output is what? Is this only this star? And how many times is star? It's 45. But this is not generating any number on the output side. So therefore it is void here. So void and the name of the function, and these two small parentheses which will contain the input to the function. Now this, at the moment this small parentheses are empty, that means there is no input to the function, and then there is no output of this function, right? So what this function does, it only performs this task, and that is generating 45 stars, right? So you can mention this void in the small parentheses as well. This is what we usually do in C programming, but in C++ there is no need to mention the arguments of a function as void. If there are no arguments to a function, then it is by default it is understood that arguments are empty. There is no argument, it means it's default, it is void by default. And still if you want to mention void for your understanding, then it is also okay. I mean, if you want to put the void within these small brackets, then it's also okay, but there is no need of mentioning the void within these brackets, right? So the idea is, this is the function which will perform some task, and whenever it performs some task you need to give input. So the input are the arguments, and whenever this performs some task, it will generate some output, and this is the output here. This is the nature of output. I mean, this is not the output, but this is the nature of output. The nature of output in terms of mathematics is whether it is a number, it's a character, it's a symbol, it is what. So you have to mention it. But because this function is not generating anything, so meaning there's no output of this function, so therefore it is void here. void, void means null, empty. Now, whenever you call the function, it will directly jump to this line here, meaning to the main function body, and it performs its task, and then it will come back or bounce back to the main program again. That's how it performs its job. So I hope the concept of function is clear to you, the declaration is clear to you, the function calling is clear to you, and then function definition is clear to you, and what these arguments means and what this void means here. Right? I hope these things are clear to you here. Now let's talk about the function call. Right? So I will already explain to you, but let me do it once more. Function call always happens within the main program body, and the main program body is the integer main. Right? Main is also a function. Right? So see, main is also a function here, and what kind of output main will generate? The output of main will be integer. Now this main is a built-in function. It is not user-defined function. This star line is a user-defined function. Right? So I will explain to you the difference between the user-defined function and built-in functions. But see here, this is the built-in function, and the output of this function will be integer, and there are no arguments, there are no inputs to this function. Right? Now whenever you call the function, you always call the function within the main program body. Out of the main program body, you cannot call it. Right? So whatever is happening in the program, it is only happening within the main function body. Right? So I mean main program body. So you call it, whenever you call it, you basically jump to the function body, and once this task is being done, then you bounce back to the main program again. Right? But keep one thing in mind, whenever you call the function in the main program body, you will not mention void or whatever the nature of the output of that function will produce. You will just only write the name of the function, and then you give two small parentheses. If there are any kind of arguments, then you will mention the arguments, but you will not mention the nature of output. Right? Keep this thing in mind. Whenever you call the function, you will never mention the nature of the output that function will produce or generate. You only mention the empty brackets if the arguments are empty, and you can give the arguments within the function call, but you cannot mention the nature of the output. Right? So this is the idea of the function call here. And then finally, function definition. So function definition is a very pivotal part. Function definition means what kind of task that function will perform. Now this may contain for loop, this may contain while loop, this may contain do loop, this may contain if else structure. It can contain any concept of OOP. Right? It can contain anything. That means this is the main. This itself is a program. This itself is a program, but it is out of the main program body. Right? And the reason of keeping this main out of main program body, I'll explain to you. But at this moment, you need to understand this itself is a subprogram which is doing some kind of job. What kind of job it is being doing, it depends upon how you want to use it. Right? Now let's suppose that we want to use this function for generating 45 stars. So we have used the for loop which starts from 0 and it ends on 45, less than 45, that means 44. So from 0 to 44 means 45. So that means we want to have the stars for 45 times. This is the function that is being performed by this function. I hope this is very clear to you now. Right? Now this is called the function definition. Now function definition is a very first line that is called declarator. Right? This is the declarator here. Right? Y star and declarator. Again, it is void here because it is not generating any kind of output which is number in nature or character in nature or something. Therefore, it is mentioned void here. And because there are no arguments to it, therefore the arguments are also empty. So argument simply means input to the function. Right? And what kind of output it will generate will be mentioned here. So there are some more examples coming soon which will be having some different nature of the output. It will not be void in nature for sure. Right? Now let's talk about the syntax of the function. Right? So the syntax of the function is you basically mention void If it is not generating any kind of output, it is empty. And then name of the function. The name of the function always and must always be suitable, meaning that what kind of task it will perform. So you mention accordingly, and then you give two small parentheses, and within the parentheses you mention the arguments if there are any arguments available, and then you give the semicolon. That means you terminate it. Now this is called the declaration, and declaration always happens before the main program. Right? Like the structures are being declared before the main program, enumeration are being declared before the main program. Likewise, function declaration happens before the main program. And then within the main program body you basically call the function, right? So you basically call the function to perform that specific task, right? This is the syntax of function, right? So whenever you call the function, right, in the main program body you will never mention the void. So you see there is no return type. So you will not mention the return type here. Just you write the name of the function and then give the small parenthesis, and then you give the semicolon. And in the function definition, again you have to mention what kind of output it will generate, what is the name of the function, and what are the inputs to the function. But you will not give semicolon. You will not give semicolon because it has its own function body, right? So because there is function body, therefore you will not mention semicolon here in the function definition. So step 1 is declaration, step 2 is calling, step 3 is definition. So declaration always contains semicolon, and the nature of the output, the name of the function, and the inputs to the function if there are any. Function calling will never contain the nature of output, but it will contain the name of the function and inputs as well if there are any input. But you give semicolon, and then again you write the main statements of the program itself. In function definition, you always put the nature of output, integer, character, float, long, double, wide, whatever it is, and then name of the function, then small brackets, and within small brackets you basically mention arguments if there are any arguments available. Then you will not give semicolon, but it only because there is function body itself, and within the function body you basically does the function job, right? Whatever mathematics you want to do, you just put there. Now these 3 steps should be very clear to you. Now the summary is given here. First thing is declaration, then calling, and then finally definition. And within the definition, the main thing is the declarator. So whenever you declare the function, declaration means before the main program body, right? And before the main program body is this thing like void and the name of the function and then semicolon, right? And calling the function will never contain void, meaning the output nature will not be mentioned, only the name of the function and small parentheses and arguments if there are any. Definition means main thing of the function, the heart of the function, right? So what function does, you will mention everything here, line of codes, bunch of statements within the function body. And the first line in the definition of function is called declarator, right? So this is the declarator here. Declarator means what inputs it has and what outputs it will generate, right? So give the input to the function, it performs a task, and then it gives you output. So you give all 3 things in the declarator. Right? This is how the function does their job, right? Now as I mentioned earlier to you, there is a difference between the user defined function and built-in functions. Now one of the functions that we have been using excessive ways, get character echo. So I hope the function of get character echo is very clear to you, so I will not go into the function of it. But remember, the get character echo has one library, that is CONIOH. CONIOH is console input output, right? So whenever you use this function, you basically mention the library of this function. So whenever you use whenever you use the built-in functions, you do not define them. You only declare them, and you declare them in the library, right? So whenever you mention any library for any function, that step is known as declaration. And then you only call them, right? So calling, as I mentioned to you, only happens in the main program body. So in the main program body you mention character, get character echo, and then you give small parenthesis. So small parenthesis contains argument, and this is the output of this function. That means whatever input you give to this function, it will perform this task, which is get character echo, and finally it will return you the character. So I hope you remember return thing. Return thing means whatever the function will generate on the output side. So these inputs here, then the task, what function it will does, and then finally what it will return to you. So whenever you use the built-in functions of C++, then you declare them in the library. So whenever you put header file hash include this, hash include this, hash include this, for get creator echo, the library is hash include conaio.h. This statement simply means you are declaring the function. The mentioning of library simply means at some point in the main program body you are going to use that one function, right? Now this library may contain many functions, right? Likewise, like this function, this library can have so many functions, but only we have used one function so far, so I'm only discussing that function, right? Now where is the definition? So you might have the question that where exactly the definition of the function is. So definition of function is actually in some other file, but whenever you execute your main code, automatically linker, there is one thing called linker, will connect that header file with your source file, right? That is the task of linker, is to connect the function body of the built-in functions with your source file. So this is slightly ambiguous at the moment, but I will try to explain you. The idea is that whenever you use built-in functions, you declare them. So declaration happens in the library. So whenever you mention library, that means you are basically going to use one function which relates to this library, and then you do not define it. So definition of the built-in function never happens in the main program body. So the definition of the function is kept somewhere else, but when you let know the compiler that I am using this function, and whenever the compiler builds your program, it automatically links the definition of that function to your main source file. So the source file is .cpp, that is like your own file that you are developing. And what linker does, the linker basically connects the definition of built-in functions with your source file, and then finally generates one output, right? Now it is also very possible that we can eliminate the declaration, right? So let me show you that portion, that like as I mentioned to you, that there are two approaches. One approach is declare and then define, and other approach is define and then declare. So it is also very possible that let's remove the declaration, let's not use it. Let's have two steps only. One step is definition, and second step is calling or invoking, right? And let's expunge the declaration. That is also very possible in programs. Now this program, if you see here, does not contain any kind of declaration here. So if you see the library is here, IOStream using namespace std here, then if you see there is no declaration here. Directly there is definition, and what definition contains? It contains that statement from 0 to 44 and then asterisk symbol. And in the main program body, we are only calling those functions like starline here, and starline here, right? So this starline is being called 3 times here, 1 time, 2 time, and 3 times. But if you see here, there is no declaration. So what we are doing is we are expunging declaration from our main from our entire program. So step 1 we have done is we have defined the function, like we have defined the structure earlier, and then we have done for the enumeration as well, and then we have used them in our main program, right? But right here we have not declared the function, but directly we have defined it and then we have called them. This is also possible, but this is not a good approach. This approach works on smaller programs which contains only one function, but if you have large number of functions like 2, 3, 4 functions, then this becomes slightly difficult, that which function we should keep first and which function we should keep second, right? Or which function we should keep third. So then this becomes very much complex. So it is always a good idea to declare it and then use it and then finally define it, right? And the second reason of not using this method is our program always starts with integer main. So if you start your program directly with the function's definition, then the new programmer will get stuck that there are 4 to 5 functions are there, and then main program starts, right? So this becomes slightly difficult for a new user to understand it. So better to avoid this approach. Try to declare it, then you call the function, and then finally define it. I mean, definition always happens at the end. So you should have a clear concept that my function will be doing this job. So you keep that main function body at the end of the program, and you basically start your actual program from integer main. And so that would be easy for you. And at the top, after the libraries, you just mentioned declaration that these functions will be definitely called soon in the main program body. So if there's only one function, then there's only one declaration. For function, for declaration, and then main program body, and finally depends upon how many functions you have, you just define them. 4 functions, 4 definition, 3 functions, 3 definitions, 1 function, 1 definition. And that would be easy approach for you if you have so many functions, like 4 or 5 functions in your program. But if you have only one function in your program, then, and you really understand that, I mean, you can really separate the function definition from the main function, I mean integer main program body, then it's okay. But if you cannot distinguish it, if you cannot differentiate it, then better to avoid this approach and go with the declaration, calling, and definition approach. Right? That would be much better for you. Okay, so let me explain to you the next very pivotal concept, which is passing arguments to a function. Right? Now, passing argument doesn't mean that fight happens within the girls. Passing argument, I'm just joking. Passing argument simply mean that you give input to the function. And as I mentioned to you, there is always input to a function, and then what kind of function, what kind of task that function performs, it will generate one output. Right? So you need to give input, like that is what generally happens in engineering, that we give input, then there is system, and then finally we have output. So the input to the function is called passing arguments. Right? So passing arguments means you basically give input to the function. So the input can be a constant number, input can be a variable, input can be a character, input can be a structure itself, input can be an enumeration, it can also be an enumeration. Right? So there are so many things that we can give as an input to a function. It is also very possible that we can give function itself as an input to a function, which will be a complex thing, but definitely it is possible. But at the moment you need to understand that the input that we give to the function is called as passing argument to a function. And this task is being done by the main program. I mean the main program body. So main program body will basically give input to the function, and then function will perform the job and give a one output. Right? So I hope this makes sense to you. So the passing to argument means you give input to the function. Right? And who gives the argument? The arguments are being given by the main program. Right? And what kind of argument we can give? We can give constants, we can give variables, we can give values, we can give structures, we can give enumeration, and if you want to make much more complex things, then we can give function itself as an input to one more function. That's also very possible, but we will do this thing later on. In this video I'll explain these 4 stuff. Constants, I mean how we can give constant as an input to the function, then how we can give variable as an input to the function, and then value as an input to the function, and structure as an input to the function. Right? So these 4 things we'll be giving as an argument to the function, and then function will perform its job and will give you the output. So at the moment the nature of output is not decided, that is return, right? What function will return to us? Let's suppose that your parents are investing in you, that is input, and you are doing some business at the moment, and then finally after 4 years you will definitely get some job, and that is the output, right? You know, at small level that's the output. So that's how the function works basically. And then just give you a stupid example. Now let's talk about example by passing constant to argument. That's the very first thing, right? So let's give a constant number or character as an argument to a function. Right? So let me show you that example first, and then I'll explain to you in detail. I think this example here. Let me zoom it. Now if you see here, in declaration it is clearly mentioned that argument or input to the function are character and integer in nature, right? So now I will not be using the word argument again and again. I will be using the word input because I am comfortable using the input, because being a good engineer I am comfortable with input and output. So I mentioned input here. So the input to the function are two inputs. One input is character and one input is the integer. These two inputs are separated by a comma here. So you can directly specify the data types here. One data type is the character and one data type is the integer. So definitely these two, the values of these nature will be given by the main program body, as I mentioned to you. So the arguments will always be passed by the main program body. Now if you see here in the main program body, it is mentioned integer main, then there are two curly brackets which are the main program body, and then we have the name of the function, that is representation of the characters, rep character here. So it's mentioned in acronym here, so rep char. So and then again arguments, and then arguments are in single quotation mark we always mention character. So one character is this hyphen symbol and then comma, and then second argument is 43. So 43 is a number, so that is of integer nature here. So character is this thing and integer is this thing. And again there is a one more cout statement here, and then again we have called the function, and then function has two arguments. One argument is equals to symbol, and symbols are characters, so characters are mentioned in single quotation mark, then comma, again one number, and then number is the integer here. Then the same program body which we have done earlier, and then again we have called the function, that is again a single quotation single hyphen here, then comma, and 43 is the number. Now this gives us flexibility, right? So in the last program we have only generated star 45 times, but in this program we have different symbols being generated different number of times. So what we have done is we are basically giving these values, right, that are being passed by this function, by this program to the function argument. So automatically they will be linked to this. So character is this thing and 43 is this thing. So whatever nature you mention on the top of the input variables, you mention variable exactly in the same way. So if you mention float here, this need to be float. If it is like character, then you will get the error here. Now in the function definition, if you see here, in function definition we have only mentioned the for loop here. In for loop we have not mentioned the upper limit here. What is the upper limit? Upper limit is this integer n. And what is integer? Integer will come from this integer, and this integer will come from these values 43, 23, 43. So upper limit is not specified here. And then character, so we have mentioned character on the output side. What kind of character? It is not mentioned here. And this character will be asked here, and this character will be given by this main program here. Right? So let me explain to you this thing once more. In the last program we have directly specified star on the output side and 45 is an upper limit. But in this program we are not doing this task. What we are doing is we are trying to have much more flexibility. And the flexibility is we have mentioned the data types as an argument of a function. Right? So we know that this function will be called in our program, and this program will give the values to the arguments, and then values are this single dash symbol and 43 number. So single dash symbol is a character and 43 is a number, again equals to symbol, and 23 is a number, and this single space are hyphen and then 43 here. So you can give argument to the function directly, but you need to mention the nature in the declaration and as well as nature in the function body here. So if you see in the function body we have mentioned that character, and then there is a variable integer, and then there is a variable. So in declarator, in the function body, you have to specify everything, right? What kind of output it will generate, what is the name of the function, and what kind of input it has, and what kind of variable it contains. So character, ch, integer, n. Now because it is flexible, so we have not specified upper limit here. So upper limit will be given by this number here. So this number is 45, 43, 23, 43, whatever the number is, automatically that number will be 43 here, 23 here. Whatever character we will mention here will automatically go here. Right? So we just in this way we can make it slightly flexible, and that is the idea. Now let me show you the output of this program on the code block here. So I have this program here. I think some other program is running on the backside, this one here. Now let's build it and then run it. Now if you see here that there is a single space here, I mean hyphen here, and then there is equals to symbol, and then again single symbol or hyphen symbol here. So this probably is 43 times, then this is 23 times, and again there is 43 times. So you can give constant values from the main program to the arguments of the function, but in the arguments of the function you need to mention the nature of the input. The nature of the input means you need to mention the data type in the function declaration, right? But whenever you do the function definition, in function definition you need to tell every truth. But every truth means you need to assign the variables as well, and these variables will automatically be these variables will automatically be replaced by these values. So whenever you do the function body, in function body you have to specify everything. You have to tell every truth, like what kind of output it will generate, what is the name of the function, and within the arguments you need to mention data type, and you also need to mention the variable name. So these variable names can be different from these variables here, but they will automatically be changed, or they automatically will be equaled, right? So you have to mention this everything here. And so this is the a argument, constant argument being passed to a function, right? So by the main program body, right? Now next thing is variables, right? So we can give variables as an argument to the function. That's also very possible, right? So let me show you that program, and then I'll explain to you. So I think this program we have done. This program here is a variable here. Full screen. Okay, right here I have the program. So I have mentioned the character and integer here. So I know that argument or input to this function are basically the character and integer in nature, and these values will be given by the main program body, right? So if you see, if you expunge momentarily for a while, if you expunge this line, then you see that there is library using namespace std and then integer main, which is the built-in function, and within the program body we have mentioned two data type here. One data type is character and the variable is character in. Second is integer and the variable is n input. N input is number input, right? So in the first statement we have mentioned enter a character. So the character will be entered by user, and that character will go in character in variable. So this will be stored right here. And then we are asking enter a number, how many times you repeat it, and that number will go to this n in, and that will be saved in the integer here. Now these two values are now the argument of a function. So one is character in here, comma, n in here. N in is integer, so you see integer here, and character in is a character, so see character here. And if you swipe the position, like n input comes here and character input comes here, then you will not get the proper output, and you will definitely get the error, because first position is of character and second position of is the integer. So I simply mean here that in the last program that was constant, and this program there are variables. So we can assign variables to the function argument. That is also variable. That's also very possible. Now in the function body, if you see, which is the main part in the function body contains its own variables. So see, the data types are very similar, character and integer. Character here, integer here, character here, integer here, but the variables are different, ch and n. Right here the variables are chn and n in, mean character input and number input, and right here there's character and n only here. You can keep the same variables as of the main program here, but that's also okay if you change them, so they will automatically be equaled. That is also very possible. And in the function body there is the number from 0 to n, and what is n will be given by the user, and what is ch will also be given by the user, which will be equal to chin. And so we can give, so the conclusion is we can give the variable as an input or as a function argument. That's also possible. And the name of the variables can get changed in the function body. So if you come in the function body, the data types will remain same, but the variable names can get changed. So if you want to keep the variable name same in the main program body and in the function body, it's also okay. But if you want to change them, that's also perfectly fine, right? Okay, so let me show you the output of this program on the code block here. So this on the code block I have this code here, which I have just explained to you, and let me run it for you. It probably takes some time. Yep. So first input is enter a character. So I'm entering, let's say I'm entering my P here. So let P here. And then it's asking number of times. So my lucky number is, okay, I'm not telling my lucky number. So let's say 25. 25 times I want to run it. So see here. So the P is being displayed 25 times. So if you count it, definitely will be 25 for sure. So, right. Let me run it again. It's just, funny stuff. Interesting stuff. So let's say the number is character is S, and number of times, let's say 17. So 17 times S is displayed here, right? So the idea is, first step was we can give constant as an argument. Second is we can give variable as an argument to a function. Argument means input to a function, right? Now the next thing is, right, so this is what happens, right? So let me summarize this thing. So in the main program body, the variables are different. The variables are character input and number input. But in the function definition, the variables are different, ch and n. So automatically they will get equal. So this ch input will be equal to ch, and this n input will be equal to n. Right? This is also okay. This simply means you can change the name of the variable, but the nature need to be very similar. You should not change the nature. Nature means the data type. The data type need to be very similar all the time. And that's simply it means. Now, important thing is the structure. So we can give an structure as an argument. So remember, structure is very amazing stuff in C++. So we can give a complete structure as an argument to our function. So let me explain you how you can give a structure as an argument to a function. So let me show you this thing by the program here, right? So we have already covered this program in the earlier chapters, but let me show you this thing right here. Now see, this program contains libraries on the top, then it contains the structure, then it contains the function declaration, then at some point the function is being called here, and then it contains the function definition here, right? So these are the 4 to 5 parts here. So in the start, I think the libraries, I need not to explain them. Then the structure is always mentioned, is always declared before the main program body. So you remember the main program body is integer main, so the structure is being declared before that. Now the name of the structure is distance, and now this distance in the main program will act like a user defined data type, right? This thing should be very clear to you. Now this structure contains 2 variables. One variable is feet and one variable is inches, and the feet is of integer nature and inches are float nature, right? So I hope this structure is very clear to you now. Now then there is a function declaration, and the name of the function is English display. That means English system distance display. And so the way we display the distance in English metric system is what the name of the function is. So English display, ENGLDISP. So you always give an appropriate name to a function which depends upon what kind of task it performs. Now see here, there's void mentioned. Void means it will not return any value to you. So that is why it's void here. And then the name of the function, and within the parenthesis the data type is mentioned, and that is distance. And this distance is basically a user defined data type. It is not integer, it is not character, it is not float, long, double, but it is distance, and this distance is basically a name given to the structure. So you know that the name given to a structure in the program basically functions like a user defined data type. So in the small parenthesis we are basically giving this distance as in a data type here. Now within the main program body, this distance again is being used as a user defined data type here, and it contains two variables, d1 and d2. Right? Now from statement here, cout statement, we are asking user to enter a feed. So now this is stored in d1.feed. d1.feed means this d1 variable will be accessing this feed here, and then we are asking to enter the inches, then d1.inches. Again we are asking the user to enter the feed, so d2.feed, so d2 and then dot feed, and then d2.inches. So I think this thing is very clear to you now. Now in the cout we have mentioned distance 1. d1 means distance 1, and then we have called the function. Whenever we call the function, it directly jumps to this function body. And now when we call this function, it has an argument that is d1. And what is d1? d1 is like this feet.inches. So if you see here, whenever you call this function, it automatically jumps to this point. And what is the argument to this function? That is the distance in nature, and the variable is dd. So the function definition can have its own variable. So this is the data type here. This data type need to be very similar to the declaration here, right? And now the variable is dd. So dd.feet, and then there is a single quotation mark for the feet, and then double quotation mark for the inches, then dd.inches here. So whenever you call this function to display the distance 1, it will execute this statement for you. And what is feet.inches? Feet.inches are these values we have taken from the user. And then again d2, that means we want to display distance 2. So we have called the function here, and then function will jump to this point, and again it will display the same values that we have taken for the d2 here. So d2 means d2.feet, so feet will come here, and then dot inches, so inches will come here. And this is like escape sequence here. So double quotation mark means it will display this double quotation mark means it will display whatever mentioned inside here, and what is mentioned inside here is this escape sequence here. And what is escape sequence? That is backslash and this single quotation mark, and then again a space. So whenever the output comes, that there will be a single quotation mark, that means it is for feet, and then hyphen, and then double quotation mark for the inches. Right? So I hope this program is very clear to you. Even I will again repeat this thing for you once more. Library is here, and then there is a structure, function declaration. Function declaration must contain data type, and that is distance, and distance is user defined data type here. Now in the main program body we have used distance again, and that contains two variables, d1 and d2. d1 will store the first information, and d2 will store the second information here, that is d2.feet and .inches here. And then we want to display it. So for display we are basically calling this function. What this function is doing is only displaying those values which we have taken from the user. So when you call this function, it jumps here and then displays dd.feet. So dd is what? Is the variable of distance in nature. What is distance? Is this thing here, right? And this contains d1. d1 is what? Feet and inches both. So therefore it's feet and inches here. Right? So we can give a structure as an argument. So let me show you the output of this program on the code block here. So I have this code here, and let me compile it and then run it here. So let's enter the feet first. Let's say feet are 5, and let's say inches are, let's say, 9 inches, and then again it's asking for second is like, say, 7 feet, and say inches are, let's say, again 7 feet and 7 inches. So see here, so d1 is 5 feet 9 inches and d2 is 7 feet and 7 inches, right? So whenever this d1 is being called, this function is being called, it will jump directly to this line here. And what this line is doing, it is only displaying that feet.inches. So first feet are being displayed, and then if you see on the output side, there is a single quotation mark. So single quotation mark is coming by the escape sequence, and then there is a hyphen, there is a space here, and then 9, and then there is a double quotation mark for the inches here. And that's how it works. Now there is one more interesting program which is based on graphics. Therefore I have taken one complete week. I spent almost 4 to 5 days to run that one program from the last Friday till the Monday. So this video got delayed. Otherwise there was no any reason. So I installed couple of compilers like Dev C++ and Visual Studio and so many other compilers. Gordon, none worked properly. Only Visual Studio 10 worked properly. Now I'll show you the program first, and then I'll show you the output, right? So this is the program here. Probably I have this program somewhere here. Maybe I've not opened it. This program is right here. Okay, this program will display the circles of different nature. Now if you see on the top, library is quite changed. This is Microsoft Console.h, MSoft CUN.h. It means Microsoft Console.h. Now this library is a graphics library. Now this library is quite outdated. When this book was written, the library was used at that time. Now the library is graphics.h. So if you are using CodeBlock or some other compiler, then library would be graphics.h. But because this is mentioned in textbook, so I have to explain to the program as it is. Therefore, I have done my homework just to show you this program. So if you see, there's no library like IOStream and Conio and all those things, because there are no functions are being used of such nature. Only this Microsoft Console.h is being used for the graphics purpose. It is clearly mentioned for graphics function. Now there is a structure being used here. So structure is declared before the main program body. So structure has the name of circle, and circle within this structure body, if you see, there are 4 variables. One variable is integer, which contains there are 4 data types here. One is integer, which contains x coordinates and y coordinates. One is integer and then radius. So these 2 are the variables, x coordinate, y coordinate, and they are of integer nature. And then there is one variable called radius, and it has a nature of integer here. Then there is this data type is color. Color is a data type which belongs to this library, and I'll explain to you this library in detail in our upcoming videos. But this is not the built-in function, but this is being done by the author. So this color is basically a data type here, and it has a variable of fill color. And then f style is also a data type here, and it has a variable of fill style here, right? So it contains 1, 2, 3 and 4 data types here, and then 2 are of the same nature, and these contain these variables: x coordinates, y coordinates, radius, fill color and fill style. These are all the variables here. And this structure has a name given circle, and this circle will act like a user defined data type in our main program. Now we are calling one function, and that is void circle draw, and then so this void, so if you see, there is no function declaration. There is no function declaration, there is only definition, right? So the function is being defined here, and that function will not return any kind of value, so therefore it is void here. The name of the function is circle underscore draw, so you can give such kind of name depending upon which kind of task it performs. And then the arguments to the function. The argument of the function is data type and the variable. So data type is what? Circle. Circle is mentioned here. So this circle is a name given to the structure, but this will act like a user defined data type. So right here it is being used as a data type here, and it has a variable of C. Now it has these 3 I would say tasks to perform. One task is set color, one task is set fill style, and one task is draw underscore circle. And the arguments to each of these are basically the functions. This function, this is also function, this is also a function, and these are being mentioned in the library of this one, which I will show to you now. Now these are the arguments. One argument is c.fillColor. So by this C we can access these values. So circle, to access this circle we need to mention one variable. So by using this variable we can access these things. So we have c.fillColor, so we have accessed this fill color here. Then c.fillStyle, so we have accessed fill style here. Then c.x coordinate, c.y coordinate, and then c.radius. So this function contains these all stuff. Now we have to initialize the graphics, so we have initialized the graphics here. So this is also a function of this library here. And then circle is a data type, and it contains the variable c1 and curly bracket. Now this is like a structured stuff here. So 15 is first thing, which is x coordinate, 7 is y coordinate, 5 is the radius, C blue is the style, and then x fill is the fill color, right? Then again 41 is the x coordinate, 12 is the y coordinate, 7 is the radius, which is this thing, like 3 arguments. Then the 4th argument is red, which is the fill color, and then O underscore fill. This is the pattern, this is the design I will show you now. 65 is again the x coordinate, 18 is y coordinate, 4 is the radius, 3 arguments. Fourth argument is the color, which is green in nature, and then medium fill is the design in which the circle will be filled. Finally, circle draw, circle draw, circle draw. These are 3 circles which will be plotted on the output console, and then set cursor. Finally, we'll set the cursor on 1,25. So these all functions. This is also a function. This is also a function. This is also a function. These all are the functions which belongs to this one library. So if you do not have this library, you cannot use these functions. But at least you need to know that this structure contains these variables: x coordinate, y coordinate, radius, fill color, and fill style. And these variables are being accessed by this variable here. And this variable is basically of the nature of circle data type here. So we have accessed them in our main function here, and then we have initialized the graphics here, and finally to plot these functions we have basically put these values here as per the arguments required here. So first argument is 15, which belongs to x coordinate, 7 to the y coordinate, 5 to the radius, C blue is the color, and then x fill is the design. So now let me show you this output, and then I will show you the library of this Microsoft console.h. Right? So I will go to the Visual Studio here. So this is the Visual Studio environment. This is quite a new compiler. I mean, this is very old compiler, but it is quite new to you. So I will build it, and then finally I will run it. So these are the outputs. So see, this one is blue in nature, blue in color. This is red in color. This is green in color. So what we have mentioned in the program is this thing here. So first we want to have output of blue nature. So first output is of blue nature. Second output we want is of red nature. So this is of red nature. Third output we want is of green nature. So this is of green nature. This is x. So if you see closely here, there are x mentioned here. So this is called x fill. O underscore fill, these are like O filled are here. Then there is a medium fill that is like plus minus medium fill here. The radius of this one is 5. The radius of this one is 7, and the radius of this one is 4. So if you see, this one is bigger one, then this is smaller one, and this is quite smaller one. So 5, 7, and 4 are the radiuses. 5 of this one, 7 of this one, and 4 of this one. And then 15, 7 is like the coordinate. So 15, 7 for this one, 41, 12 is for this one, and 65, 18 is for this one. So these all can be plotted only if you at least spend 1 week. So I have spent almost like 3 to 4 days to get this program run. It will take a huge amount of time. However, I will show you the library of this one. Right? I mean this library now. Now this library is somewhere here. I mean this library is here. So if you see closely here, it contains initialized graphics. Initialized graphics we have used in our program. So initialized graphics we have used in our program here. Right? This is the and this function belongs to this library, and so we have used this function. And then we have used this set underscore color, set underscore fill, and draw underscore circle. So let me show you. So see here, set underscore color, right? This is right here, and it contains these arguments. Right? Set underscore fill, it must be somewhere here. Then we want to draw circles, so circle are here. Okay? So the library for this one is this library here, Microsoft console.h. Right? So I will explain this all stuff in complete one video: how to set up this program, how to run this program, how to use MS Visual compiler, and this is basically a multi-file program. By multi-file program means the source file is this one. This is the actual source file which I have run and I have shown to you right here in the PDF file here. Right, this is the actual code, and this code contains so many functions. Right, so these functions are basically mentioned in one more source file. So if you see, these functions are basically mentioned in this source file. So like the initialized graphics contain this code. Right, so like this is the function definition. So this is the function, and this is the definition of this function. Set underscore color is this definition here. Set underscore cursor, the axis has this definition. Clear screen is a function, has this definition. Clear line is this function and has this definition. Draw circle is a function as has this definition. Draw line is a function as has these definitions here. Jira pyramid is a function and has this definition here. So these all are the functions, and these all functions belong to one library, and that library is called Microsoft Console.h, and this library is being created by the author, and we'll definitely cover how to make our own libraries in our upcoming chapters. So this is a multi-file program which contains the source file, which is this one, which basically helps you to generate the output, and to run these functions you need to have the proper header file, which is this one, which contains only the declarations. So if you see, these are only the declarations, right? So library only contains the declaration, and the definition of all these function is available in one more source file. So this source file contains the definition of the functions. So definition of function in this file, declaration of the function is in this file, and then actual code. So as I mentioned to you, whenever you use built-in functions, then you do not declare them, you do not define them, you declare them only in the library. So we have declared them in the library, and then we are only using them. See, so we have only used them, we have not mentioned the code of circle draw. Circle draw has this code. If you go down there, circle draw has this much code. This is complete code of circle draw here up to this point. So we have not written the code of circle draw, we have only mentioned the function here, circle draw. So if you want to write this code 3 times 1 2 3, so we like this, the size of program become too large, right? So I mean, there are so many things to go. This chapter is very interesting, and this chapter contains so many broad concepts of C++. I hope that you have enjoyed watching this video, and this chapter is quite huge, and I have only covered two things of this chapter, which is what functions are and how we can pass the argument to the function. So we can pass the argument to the function by the means of constants, by the means of variable, by the means of structures, by the means of function themselves, like these 4 ways. So we have only covered these 2 topics, simple function and passing argument. So in the next video I will try to cover as many topics as possible. I will upload these all files on the VLE, you may access from there, and if you have any question, then you can drop me on the WhatsApp group or on VLE on my email address, wherever you feel convenient. And thank you, and have a good time. Take care, and Allah Hafiz. And please don't forget to give me a feedback on this video.